Hello everyone. Our lesson today it's about total internal reflection. What do you mean by total internal reflection? Firstly, reflection, the word reflection, we said when the light will be reflected. Then internal, what's that mean internal? Firstly, we said any light to reflect, it needs what to reflect? It needs a mirror. So, total internal reflection. The inside explanation for it. The inside surface of water, glass, or other transparent material can act like a perfect mirror depending on the angle at which the light strikes it. In another meaning, what do you mean by it? Take a look on this three drawing. Here, what do we have? We have water, air, and the same thing for the rest of drawings. Here we have source of light, lamp. When a lamp, it gives light. When light, it passes from water to air. So here what will happen? Some of the light will reflect and some of it will refract. Focus on these two words, they are not the same, okay? Refract, it means bending of light, and here reflect, it means bouncing. Here, the same thing. What do we have? Also we have light and reflected and refracted. But if you look at the first one and the second one, if you will compare between them, you will see the difference between these two. It's what? It's the angle. Okay, look at the angle, the size of angle. Here, I, the letter I, it represents angle of what? Angle of incidence. Why? Because we said this ray, it's what? It's the incidence ray. The ray splits into refracted and a weaker reflected. Okay, this ray will split into two rays, which are reflected. Here it's the reflected ray, and here it's the refracted ray. Here, the angle will change. Okay, when the angle will change, it will affect on the refracted and also reflected ray. But how? See, now we call this angle critical angle. Okay, when it's critical angle, see what happened. The ray splits, but the refracted ray only just leaves the surface. Here the refracted ray, it leaves the surface. But here, look at this arrow. This, it represents the refracted ray. When in the critical angle, what will happen? The ray will split, but the refracted ray only just leave the surface. If we want to give a definition for critical angle, it's what? Critical angle is defined as the angle of the incidence that provides an angle of refraction of 90 degrees. What's that mean? Take a look on the second drawing. Okay, we said it is defined as the angle of incidence. This is the incidence ray. So it's the angle of incidence ray that provides an angle of refraction of 90 degrees. Okay, this is the where is the refraction? This is the refraction here. but how much it is? It is 90 degrees with the normal. For angles of incidence greater than this, there is no refracted ray. What's that mean? Here, this angle, the critical angle, when or a degree just above the critical angle, what will happen? There will be no refracted ray. All the ray or the incident ray will reflect. This we call it total internal reflection. Look here what happened. The C, the critical angle, here it increase. Okay, the degree here it's more than critical angle. So when the incidence angle, when the incidence angle will be greater than critical angle, so then all the light will reflect. There will be no refraction. So definition for total internal reflection. It's what? The complete reflection of a light ray reaching an interface with a less dense medium with the angle of incidence. Or if you want another definition, you can say the complete reflection of a light ray. Then, critical angle, each transparent medium, it has its own critical angle. For example, the critical angle of water is 49 degrees. Acrylic plastic, it's 42. Glass, it's 41. Diamond, it's what? It's 24 degrees. Reflecting prisms. Reflecting prisms, if you remember, last lesson we talked about prisms. We said prisms, it's a triangle shape. It's made up of glass or plastic. Okay, when the light it passes through it, it deviates or it refracts. So some uses of total internal reflection. For example, here we have 3 examples. Periscope. This is an instrument for looking over obstacles. Prisms reflect the light, although they can be replaced with mirror. Here are the uses of some instruments. The principle of it, it's what? It's using the total internal reflection. Let's talk about this example. This example, it's what? Rear reflectors, okay, on cars and cycles. Maybe you notice this. If there is a car, it stops, and let's say at night when it's dark, and another car behind it. So what will happen? You will have one car here and another car here. When this car will send light to this one, here there are some the backlights of it. It will what? It blow. It shows like it's on, but in fact it's off. So why? What happened? The inside of it, it's designed in this way. So here it's the light ray that it comes from the first car. It hit or it strikes the surface of this mirror. It bent and then will be sent back. So this is what? This is total internal reflection. Optical fibers. Optical fibers, of course, all of you heard about optic fibers or optical fibers. What do you mean by optical fibers? This is optical fiber. This it's made up from a transparent material, usually glass, special glass. So what will happen? The light it passes through it. Okay. Now, when the light it passes through it, so here what will happen? There will be total internal reflection. So the light it will keep reflecting inside it until it goes out from this side. So optical fibers they have a range of uses. For example, here we have single optical fiber. Another example, bundle of opticals here, and we have optical fibers can carry telephone calls. Okay, and also here we have was taking this photograph was taken through an endoscope. Okay, here what will happen? They called it nador, like nador. Okay, they put like a fiber. It's like a camera. For example, it goes through mouth and it goes to the digestive system. Here they can looking inside the body. Questions. Question number 1. Glass has a critical angle of 41 degrees. Explain what this means. The answer: for light traveling from glass toward a boundary with air, rays at angle of incidence greater than 41 are completely reflected with no refraction at all. What's that mean? If you want to give explanation for it, when they will say a glass has incidence, it has a critical angle of 41 degrees. So what's that mean? It means the light, if the incident ray strikes the glass with an angle less than 41, the ray will be split into reflected and refracted ray. But when it reaches 41, the incident ray will be all of it reflected ray. There will be no refraction. Again, at 41, all the incident ray it will reflect. There will be total internal reflection. Question number 2. A. Copy and complete the diagrams to show where each ray will go after it strikes the prism. The question here it's the question. The question it says here it's the incident ray. Okay, when it will pass through this prism, write or complete the path of it, where it will go. Firstly, here, because the incident ray it's coming with, or it's striking the medium here at right angle, so it will reflect as a right angle. So here what is happening, it's coming by this direction. So here the angle here it's 90 degrees. Because it's 90 degrees, so what will happen here, there will be total internal reflection. The same thing it's here. Here also it's striking the prism at this angle here. This angle it's 90. Okay, so because it's 90, so it goes straight and a total internal reflection will be. Here there is more explanation for it, but for this grade you don't need the explanation of it. Just you should need to know that when a straight line a ray comes to a prism, there will be total internal reflection. B. If these two prisms were transparent triangular tanks filled with water. Focus on the word water here. Would total internal reflection still occur? If not, why not? Firstly, the answer, it will be no. Okay, it will not happen that total internal reflection. But the reason why. When it was prism, how much it was the critical angle of it, because prism it's made up of glass, so the critical angle of it it's 41. So when the total internal reflection will happen if the incident angle, okay, here it's more than critical angle. Here this angle it's this incident angle it's 45, okay, because it's 45, that means it's more than the critical angle, so there will be total internal reflection. But in water, a ray to reflect totally, the angle of the ray, it should be how much? The incident ray angle, it should be more than 49. But here we say it's only 45. So because the incident angle, it's less than critical angle of water, so there will be no total internal reflection. So the answer, no, because angle of incidence, it's less than critical angle. Question number 3. A. Give 2 examples of the practical use of optical fibers. Optical fibers, okay, as we said, we can use it, for example, carrying telephone signals and endoscope. Here it's endoscope and telephone calls, okay. Then B, it says give 2 other examples of practical use of total internal reflection. Total internal reflection, as you can, if you remember here, we say these are the examples of total internal reflection. So here it's total internal reflection in periscope, and also, for example, here in rear reflectors, also here we have total internal reflection. So that was everything for this lesson. I hope everything was clear. If you have any questions, concerns, please don't hesitate again to text me, and also don't forget to write your name, to write a comment when you will finish watching this video. Your task for this lesson is to solve the questions on the workbook. Thank you and have a good day.